Our next lesson is called Piecewise Functions Day 1. So I'd like you to start with the opening exercise. The given graph is a piecewise defined function referred to as f of x. So looking at the graph, I know piecewise this is what we're talking about today, so you're not familiar with it yet, but that's what we're going to learn about. However, you can see the graph kind of makes sense with what we're calling it piecewise. The graph is in pieces. So just to get you familiar with how to read something like this, you're going to do the opening exercise, and you're going to review some of the key features that we've discussed in prior lessons. So I'd like you to find the max and min, the domain and range, and you're going to evaluate some inputs and outputs. So at this time, please pause the video, try the opening exercise on your own, and then resume the video to go over the answers. Now that you had a chance to try the problems on your own, let's go over the answers. Remember, maximum and minimum are values, so a single number is written down, and this is referring to y values. So maximum would be the highest y value, that would be 3. There's a filled in circle at that coordinate, so that number counts. A minimum would be a lowest y value. So again, looking for the lowest y in the graph, it's filled in, it's at -3. For domain, we're trying to find the x values of the function. So I pinch in from the right and the left. And I can find the barriers. And I see that my domain goes from -4 is less than or equal to x, is less than or equal to 4. Since those endpoints are filled in circles, they count. The range are my y values. So I'm trying to pinch from the bottom and the top. I am, again, able to do that and find the barriers. So my lowest y value is -3. My highest is 3, again, both filled in circles, so they both count. For E, f of 4, the input is 4, which means the x value is a 4. When I look at the graph, the coordinate there is 4, -2, so my output is -2. For f of -1, I'm looking for an x value of -1, and when I do that, I see two different coordinates. I see -1, 1, and I see -1, 3. However, one of them is an open circle, so that one does not count. And the other one is a filled-in circle, so that is the point that counts. So an input of -1 gives you an output of 3. And it's going to be important for us moving forward. You can't be in two places at once, and that's why you see this happening on the same line. And we'll see that more again in some other examples. Then for G, if f of x equals -3, find x. We were given the output this time, a y value of -3, and we had to find the input. So when I find a y value of -3, I see a coordinate at -4 and -3, so my x value or input must be -4. So now let's move on and talk about what a piecewise function is. Sometimes a function's rule is defined differently on different intervals of its domain. When this happens, we have a piecewise function. When all the pieces of the function are linear, we call it a piecewise linear function. So basically the graph is broken into pieces and each of the pieces is linear. So in our first example, let's take a look at the graph that's already been created for us of a piecewise function. It says a piecewise linear function f of x is shown graph below. Answer the following questions. So in part A, they'd like us to evaluate each of the following. Let's find f of -3. Since -3 is in the parentheses, that's an input, which means our x value is -3. So I go to the graph, I find an x value of -3. I see this coordinate at -3, 2. So my output here is 2. Then f of 9, again, input. X equals 9. So I go to the graph, find an x value of 9, and find my coordinate. It's at 9, -2. So my output is -2. So you just practice that in the opening exercise as well, just again showing you how you would do that. Now let's look at part B. In part B, it says, is f of 0 equal to 4? Or is f of 0 equal to 8? And how can you tell? So again, the 0 is in the parentheses, so that means we're dealing with an x value of 0, an input. And when I look on x equals 0, we're looking on the actual y-axis. And there are two coordinates. At f of 0, I see 4, but it is an open circle. So remember what that means. It doesn't count. Then the other one, I see a closed circle. So that's the one that counts. And so then the answer to this question is f of 0 equals 8. And that's because there is a closed circle at the point 0, 8. All right. So now when we see part C, it says give equations for this function for the following domain intervals. And what I want to point out to you is that in this first example, I'm giving you the place to break the graph. You and I will practice how to find those breaks in the next example. But do you see that the place where things kind of change are at that x equals 0 line, which is the y-axis? So that's why you see the split there for x is less than or equal to 0 and x is greater than 0. And the reason the first one is x is less than or equal to 0 is because that's where the filled in circle is. And then the second one is x is greater than 0 because that's where the open circle is. So our job when we're writing the equation for a piecewise function is to write the equation for each piece. And since each of those pieces are linear, we already have a background on how to write the equation of a line when it's linear. We want to put it in the form y equals mx plus b. So that means we need to find the slope and we need to find the y-intercept. So we'll make that note. Find slope and y-intercept. So that's important. So we'll do the first portion, the left graph first. And I want to point out here that we've got an arrow. So that means we're going on forever in that direction. And again, that's why this part of the graph is x is less than or equal to 0. Because anything 0 and on forever to the left is going to use this equation. So we'll pick any 2 points on the line to find the slope. I'll pick this one and this one. I'm going up 2 to the right 1. So that means I have a slope of positive 2 over 1 or 2. And then up here, where we already talked about the closed circle, I see the coordinate 0, 8, which means my b value is 8. My y-intercept is 8. So now I know the equation is 2x plus 8. Looking at the second one, we're going to do the same thing. I got to find the slope and the y-intercept. So I pick 2 coordinates that I can easily read to find the slope. That's down 2 to the right 3. So that's a slope of negative 2/3. And here, right now, again, open circle, which matters when we were coming up with our domains. But for the purpose of finding the y-intercept here, I see that it's still 0, 4. That's where it's going to cross. We're just not going to include it in the open circle. That's why we have x is greater than 0. And that means our b value for this section, our y-intercept, would be 4. So putting that together, I'd have negative 2/3 x plus 4. And we just wrote the equation for that piecewise linear function. Now, here, the pieces, you could see where they were split. I want you to answer this question for example 2. How is the graph of this function different than the graph in example 1? Think about that for a second. Take a look at the picture. What are we noticing is different about this graph? Well, I see 3 different sections. Our first example only had 2. There's no limit to how many pieces can be in a piecewise function. You just have to write for every piece that you see. The other thing I see is there's no disconnect like example 1. You see here how there was kind of a jump. It was not continuous. It was discontinuous. Here, we actually have a continuous piecewise function. And what does that really mean? It just means the pieces connect. So we have some choice here. We didn't have choice in example 1. I knew exactly what my domain had to be based on open and closed circles. X is less than or equal to 0 had to be the first part because that's where it was closed, and the other one had to be the one with just the strictly greater than because that was the one that was open. Here, there's just a little bit more flexibility because we can decide where to count each one. So I'll show you what I mean as I move through and we write the equation for this piecewise function. So there's 3 sections. I'll start with the section all the way to the left first. I first want to mark, though, that we've got some arrows. So we have some places where it's going to go on forever. Let's mark that so we know later where to write our domain. And we'll take a look at this first portion. So we can find the slope between any 2 points. I went up 1 to the right 1. So my slope is positive 1 over 1 or 1. And I can see it's crossing the y-axis right here at 0, 3, which means my b value is 3. So already I have the information I need for the first piece. We'll write that in a second. Now we're going to move on to the middle piece. I'm going to pick any 2 points, and here the 2 points are already identified. There are no other points on the line besides those 2. So I see we're going down 1, 2, 3, 4, 5, 6, and to the right 1. So that means my slope here is -6 over 1 or -6. I also need my y-intercept, and this is another reason why I wanted to pick this example. I can't read the y-intercept from this graph. And we have discussed before what we need to do when that happens. We're going to have to find the y-intercept algebraically. So underneath, I'm going to do that. I'm going to pick 1 point off of the line. I'm going to use this point right here, 1, 4. 1, 4 is going to be my x and my y. And then I already found my slope. My slope was -6. So now in y equals mx plus b, I can plug in everything I know. Y is 4. The slope is -6. X is 1. And we will be solving for b. So this is 4 equals -6 plus b. We'll add 6 to both sides and get b equals 10. So now I know the slope and the y-intercept for my second piece. And now we'll do our third piece. So the third one, we'll find 2 points to find the slope. We're going up 1 to the right 1. So my slope is 1 over 1 or just 1. And I don't see where this one crosses the y-axis, but remember, always try to just extend the line first to see if you run into the right spot. And if I continue the slope in the direction that I'm supposed to be going, I see then that I hit the y-axis at 0, -4, which means my b value is -4. So now I have all the pieces that I need, the slope and the y-intercept for all 3 sections, to start writing the equation in mx plus b form. So I've got f of x equals, and I'm going to give one of these large brackets to show that these pieces all make up the function together. So the first portion, the one all the way to the left, had a slope of 1 and a y-intercept of 3. So that would be x plus 3. The middle section had a slope of -6, so that's -6x. And we algebraically found the y-intercept would be 10. And then the last one, we have a slope of 1. And we figured out by extending that it's going to hit the y-intercept there at 0, -4. So that's going to be x minus 4. Now we have to come up with the domain or the interval domain where we're going to use each equation because these equations only work for certain x values. And here's where we're going to talk about the breaks. So think about the breaks where the function turns. Your turning points are helpful when you're doing this. So the first place I see it breaking is up here, right? That's a change. And that's happening at 1. It happens again at 2. And so those are kind of our places we have to pay attention to. So the first section of the graph, everything is happening from an x equals 1 value and less to the left. So we're going to do x is less than or equal to 1. And because that piece meets the second piece there, it is filled in. But we don't know if it's filled in from the first piece or the second piece. So it doesn't matter. If you include it in the first piece, like we're doing, you just don't include it in the second piece. Or you don't include it in the first and you include it in the second. So I'm going to choose to include it here. We're going to take 1 and less as being the first piece. So that means for the middle piece, 1 is still my critical number, but it's not going to count here because we already counted it above. So 1 is less than x, and then we'll do less than or equal to the next turning point cutoff for x, which is 2. And then in the next section, we're going to pick up from 2, but it was already counted and we know it's going towards infinity, so this one's going to be x is greater than 2. And that's because we already counted 2 above, and then because it's pointing towards infinity, it's going to happen for everything 2 and bigger. So the one note I just want to make here is make sure you do not, underline that, count in more than one place. So again, I could have had this be x plus 3 for x is less than 1. And then I could have had it be negative 6x plus 10 for 1 is less than or equal to x, less than or equal to 2. And then the last one I could have had is x is greater than or equal to 2. There's a little bit of flexibility. Just make sure you don't count it in 2 places. I should be able to say, okay, what's f of 1 and know exactly what piece of this function to use to evaluate that. We never want to count it in more than one place. So now that we've done all of this together, I would like you to try the practice problem. A roof has a side profile as shown in the graph below. You are going to answer questions A through E, which will guide you through on practicing writing the equation for this piecewise function, and it does have some context to the problem as well. So at this time, please pause the video, try the practice problem on your own, and then resume the video to go over your answers. Okay, now that you had a chance to try it, let's go over it. It says a roof has a side profile as shown below. First question, at what x value will the function that describes this profile change from one formula to the next? So this is just trying to get you to practice to find the different places where you split up your domain. That's going to happen at x equals 6. You can see I marked it there with the same color. That's kind of where the turning point happens. B, what is the formula for the line segment to the left of that value? So remember, once you find your places that it's split, you got to write an equation for each piece. So you can see I found 2 points, used rise over run. The slope is 1/3. Crosses the y-axis is 0, 7. So your y-intercept is 7. So f of x equals 1/3 x plus 7. Then it says, what is the slope of the line segment to the right of the value stated in A? This we can find right on the graph. I chose 2 points that were already graphed. I went down 3 to the right 3, which is negative 3 over 3 or negative 1. So my slope is negative 1. But D, it said determine the equation. I still need the y-intercept. I can't find it on the graph. So remember, if that happens, you have to find it algebraically. So I'll pick 1 point off of that portion of the graph. I chose 9, 6. So my x value is 9, my y value is 6. I already found my slope was negative 1. Plug all those things into y equals mx plus b and solve for b. I get 15. So now I know that this segment is f of x equals negative x plus 15. So finally, I'm going to put those pieces together, including the correct domain intervals. So we know 6 is the splitting point. I don't see any arrows, so we have definitive marks of beginning and end. So the first portion is going from an x value of negative 3 to an x value of 6. And because this is a continuous graph, I know for sure negative 3 has to be counted because it's an endpoint and it's closed. But 6 you can choose to count either in the first portion or the second portion. I chose the first portion, so I did negative 3 is less than or equal to x is less than or equal to 6. And then the second equation, negative x plus 15, is going to be used from that 6 to the next endpoint, which is closed at 9. So I have 6 is less than x is less than or equal to 9. So we should have the same answer here. The only slight difference that might happen is if you counted 6 in the second function instead of the first one, you would have negative 3 is less than or equal to x is less than 6, and then you would include the 6 in the second portion. 6 is less than or equal to x is less than or equal to 9. And that concludes your lesson on piecewise functions day 1.